So welcome, folks. I want to give just a verbal introduction to public key cryptography. So the basic idea is as follows. There's many individuals out there in the world, and we all have credit cards that we try to keep private to ourselves, okay? And then there's Amazon. Amazon, needs to know lots of people's credit card information. Whenever I buy something from Amazon, I need to give them my credit card number and the passcode and the date it expires and all that. So, however, it's also the case that it's possible sometimes to intercept messages over the internet. So, internet providers or things, they're sending these messages back and forth. And we don't want it to be the case that the internet provider or some other maybe malicious agent, we don't want them to be able to intercept my Amazon purchase and know my credit card number, okay? So the way this is done is that somehow my credit card number is encrypted. So when it's sent, what's sent to Amazon is the encrypted version thereof, and then Amazon decrypts it. So if you and your friends wanted to create an encryption system, what you'd probably do is you'd probably meet up somewhere and you decide on a scheme where you encrypt your message in some way, and then you talk about it together, and then only the people in that conversation would know how to decrypt your message. The problem with that is that Amazon doesn't have the time to meet with me individually in a dark alley to scheme up some encryption system together with me. Right? They have millions of customers, and they can't meet in a dark alley with every single one of them. So the idea of public key cryptography, it's amazing that it works, but roughly speaking, this is how it goes. Amazon picks a private key that they know and nobody else knows, and they never release it. And I'm not saying Amazon actually does explicitly what I'm saying, but I'm giving you the rough idea. So Amazon picks a private key that they keep private to themselves. From that private key, they create a public key, okay? Then the public key, they can broadcast to everybody. When I want to send to Amazon my credit card number, I use that public key, and I use that public key to decrypt my message, okay? So anyone I use that public key to encrypt a message. Anyone can encrypt a message using the public key, but once it's encrypted, the public key alone isn't enough to decrypt it, okay? So even though everybody has a public key, folks might have the public key, they might intercept my encrypted message, but they can't decrypt it. However, Amazon, who also has a private key, can use the private key to decrypt the message. I'm going to say something blatantly false, but roughly speaking, you should think of it as follows. Roughly speaking, you can think of it that Amazon picks two very large prime numbers and multiplies them together, okay? The private key is those two really large prime numbers. The public key is the product, them multiplied together. So the public key, the product of these two primes, is shared with everybody. And then I encrypt my credit card number using this public key. Nobody else who has this large product of the two primes, this public key, nobody else can decrypt my credit card number. But once my encrypted message gets to Amazon, they can use those two individual primes themselves to decrypt my message. So this is relying on the fact that as far as we know, that it's hard to take a product of two large prime numbers and factor it to find the individual primes. So so this is not exactly what the public key and private keys are, but this is a reasonable analogy. In the next video, we'll talk about the RSA encryption algorithm, which is based on prime numbers. And if you could factor products of large prime numbers easily, you could break the RSA encryption system. It's also worth mentioning that there are now more modern custom systems. So elliptic curve cryptography is an important one. And then I think lattice-based cryptography methods are ones that potentially might be robust to quantum computer attacks. So folks are devising standards now where we'd like to have crypto systems which are robust to attacks by quantum computers. I think RSA, based on the difficulty of factoring prime numbers, is definitely susceptible to quantum computers. So if you could develop a practical quantum computer, you could break certain crypto systems that folks either currently use or have used in the recent past. Any public questions or comments or corrections? All right, thank you.